Thank you for joining us this evening. I think I'd like to just talk straight through, if that's okay with everyone, and otherwise I might lose my train of thought, which you wouldn't want. And if you want to ask questions, just perhaps save them to the end. I hope I will leave enough time for some questions at the end. You could type them in the chat box as well. As you think of things, if that would help, and I'll try and have a look through those at the end as well. So I was asked to sort of address the question of sustainable architecture, which covers loads of things, but I kind of want to focus tonight on retrofit. It is quite topical, and it certainly is. It relates to what Boris will call build, build, build. As opposed to what we perhaps should be focusing on in terms of building back better. So I'm an architect. I practice on a day-to-day basis as Good Architecture from Hertford, but I'm also director of a company called 1540 Architecture. There's 6 architects and passive house designers who are looking to maybe get involved in sort of bigger projects than we currently are involved with in our smaller businesses. And we have got 4 main sort of strands, 3 of which I think tonight are relevant to the topic. There's this question of the deep retrofit, the need to improve the performance of existing building stock. And not just focus on new building stock. One of the ways to do that is to apply principles of passive house, which obviously work on new buildings, but can be applied to retrofit as well. And I hope I can just explain a little bit about how that works. And I'll try and explain a little bit also about what passive house actually is. And then also relevant to the talk this evening in terms of sort of just healthy environments in buildings are a question of materials and use of natural materials. What I won't necessarily particularly be able to kind of go into tonight is this aspect of community-led development, which is something that 1540 Architecture is very interested in. And especially in terms of applying some of these things, not just to individual buildings, but to kind of a wider scale, either in new build or in retrofit. So on the basis, I hope we're on the same sort of imagery. But this is kind of what I'm trying to address tonight. You know, what the greatest need, as it were, that we have in terms of climate change. And then the bit about community, which we won't be able to address tonight, is there was this report produced by the DCLG a few years ago, I think when Cameron was Prime Minister, called Fixing Our Broken Housing Market, which for 1540 Architecture, kind of working in alternative procurement models alternative to kind of market-led housing is what we're really interested in, co-housing and so on. And that, I hope maybe sometime we could have a discussion about that as well. And 2 weeks ago, I think, I don't know how many of you were here when Nick Cox talked about heat pumps, but it was really useful discussion. And heat pumps have a big part to play in terms of a zero carbon future. But I think we agreed at that in that workshop that basically if everyone had heat pumps, or certainly if everyone had heat pumps and electric cars, our electricity grid will just fall over. So what I want to the first point I want to get across tonight is, likewise, whilst I am going to talk a lot about fabric improvements and so on, and in terms of what the Chancellor has recently announced, was it 24 hours ago, about insulation, yeah, we are also not going to insulate our way out of this crisis. We need to apply I think a much more of a whole building approach to various factors if we are going to succeed in reducing the energy used in our buildings and reduce the carbon emissions. And one of the big reasons for not just focusing on insulation alone is the need to think about how in a comfortable building, a comfortable, well-insulated building, you can't also forget ventilation and for the quality of the environment to avoid, well, you need fresh air basically. So if you end up with a well-insulated, well-sealed building and don't think about how you're going to provide enough fresh air for the occupants, you're going to have trouble build up. It also relates to the question of when you do improve the fabric, you need to be avoiding thermal bridges and you have continuity of insulation and so on. So hopefully, in the example I'm going to show you, I'll kind of demonstrate how that can be achieved. When I was a student back in the 1970s, the president of the RIBA then coined this phrase, long life, loose fit, low energy. And I've always kind of found that quite inspiring, really, as a way of thinking about how buildings work. And then more recently, and what one should be perhaps aspiring to. More recently, Stuart Brand, an American, wrote this book called How Buildings Learn. And he had this quite good diagram, which is useful today as it ever was, really. And thinking about in terms of the lifespan of different parts of a building. And when you're involved in retrofit of a building, sometimes you are adjusting the space planning a bit, the internal alterations and so on, maybe extending. You're certainly addressing questions of services. You might be addressing the question of the external appearance of a building and changing that. But it's this part of the structure which is an important part of the building. What we're looking to do is to kind of improve it so that it's better insulated, more airtight, and fit for the future, for maybe at least 100 years into the future. For those of you who were at the Heart Sustainability Forum conference, it was in November last year, I think, I did a presentation on Passive House there. So I am just going to quickly go over a few things. Because there's this thing about, we're perhaps familiar with miles per gallon as a way of measuring performance of the car, or what is it? Litres per 100 kilometres if we're metric. What we're less kind of used to is thinking about, well, what is a good measure for the performance of a building? And the one that I'm going to mainly kind of probably mention several times tonight is the question of kilowatt hours per square metre per annum. It's a way of measuring the heating demand of a building and relating it per square metre, so you can compare the performance of one building to another when they are of a different size. And now what you're looking to do is to kind of assess the performance of a building by looking at the losses in the kind of the blue and greys on this side of the diagram, with the kilowatt hours per square metre in the vertical axis. And then you look at internal and solar heat gains, internal being people, processes, computers, fridges, and so on. And you're left with the balance, which is required to be made up by your heating system. In this case, in the order of, say, 200 kilowatt hours per square metre per annum. Now, 1540, there is significance in the term 1540, the name is 15 kilowatt hours per square metre per annum is the maximum requirement for a passive house certified building. But 40 is also a very good number, a very good low energy number. So this is a sort of the balance in a typical 1540 house, with again the losses on this side and the gains on this side. You can see that in relatively in proportion, the heating load, heating demand is way lower, closer to 20. So we're kind of looking at somewhere here a sort of 80 to 90% saving on the performance of a typical house. And then if you actually put the y-axis to the same scale, you can kind of see what is possible in terms of improving the performance of a building down to something that's the 80 to 90% improvement that we need to do in order to stand a chance of meeting zero carbon sort of requirements and heating buildings in using low carbon technologies. And 2 points about Passive House is the principle is it's a fabric first approach, and it can really help us achieve zero carbon homes in practice. And I would kind of I haven't got time to go into it in more detail, but I would argue that is the only way we're going to stand a chance. And we should be building new buildings, in my opinion, to this standard, all of them now, and we're not. But there's also this double aspect of when you certify a building to the Passive House standard, you actually, through the processes, you have this quality assurance process that deals with the issue about the performance gap between buildings as designed not performing as they are designed. Sorry, buildings as constructed not performing as they're designed. And so you actually have this sort of quality control process and checking process. And any Passive House buildings have been monitored to death since they've been built for the last 20, 25 years, and they do perform as designed, and they maintain that performance over time as well. So it's going to be slightly awkward given that the Ben of this Ben's house is actually watching at the moment, but he did give me permission to talk about his house, because the work we did there was started with this lovely little Victorian 2 up, 2 down, really semi-detached cottage in a lovely setting. This is I'm in the south side here, facing, looking back from the garden. It had a little sort of lean-to extension here, but it was literally the 2 up, 2 down, ground floor bathroom. And the brief was just to try to extend it in a way that could create an additional bedroom and additional living space. And so I'm not going to necessarily talk about how we did that, but sorry, I didn't mean to do that. But we're going to look at, what I want to look at is the work in particular we did to improve the fabric of the original part of the dwelling. And before we did that, we did this. This is an Excel spreadsheet. It's a very complicated one. There are a total of about 30 odd tabs at the bottom, but it is the design tool that is used when working to try to assess and model of a building's performance, whether it's new build or retrofit. And in this case, and this was like a draft that was never completed, but it was to give us at the design stage just an idea of where we might be heading. And in the outline figures here, we've got this heating demand in kilowatt hours per square metre per annum, and our prediction was for this house, as extended and improved, be 56, so not 15, and not 40 even, but still a good low level. If you're looking to certify to the Passive House retrofit standard, the target is 25 kilowatt hours per square metre per annum rather than 15. And another figure that's calculated when you build this model is the heating load. And if you then multiply it by its treatable floor area, its usable floor area, you in this case, you've roughly got a basic heating load of just over 3 kilowatts, which is in theory is a couple of hairdryers. Well, I'm sure a couple of hairdryers probably wouldn't heat this house satisfactorily, but it is a low figure. And then another aspect when you're working, we're looking at in terms of air tightness, which can be tested. So you look at the test result from an air pressure test, and in the case we did an initial one during the course of construction. The figure was, I think it was actually 1.4 rather than 1.5, but I think we put that in just to give us a little factor of safety. If we were aiming to certify to the EDIFIT standard, we'd be looking to achieve 1. So what I'm going to do is just roughly, if we've got time, no, maybe not, but I'm going to flick through looking at details about how we needed to address issues around the ground floor, window and first floor junctions, and up at the eaves. This is going to be zooming through. I'll probably focus mainly on this one. So this is the ground floor, and you just need to look at these photos to see what was there at the moment, to think, this is not particularly robust. What can we do? And if you then actually look at all the moisture paths that could be affecting these timber components when they meet the solid brick walls, you think, no, it's probably best that they're not there. And so what was done in this case was to install a concrete slab on high performance insulation and maintain that and link that to the insulation as much as possible that we're going to add to the inside of the walls. And then when we come to where the first floor meets the wall, you have the very standard detail of timber built into brickwork, also susceptible to wet or risk of damp. But what we're doing here is exposing the ends of the joist feet and beginning to apply a lime-based internal coating that goes through from first floor down to ground floor, and that's providing also the airtight layer. But because lime is a sort of a moisture permeable material, reduces any of the risk of rotting around the ends of the joist, because the moisture can escape either to the inside or to the outside. You link it up to the render coatings to the walls at first floor level, ground floor level, and apply air tightness tape to make sure there's no gap between where air may pass out through the joist ends, through the brickwork. And you tie it in then with the internal wall insulation, which also applying it to the party wall, to the neighbour. And so here we begin to kind of, if you see, we're beginning to sort of wrap this, create a sort of an internal T-coat in this case, with using insulation on the inside, improved roof insulation here. So this is the joint, there's the gutter where the wall insulation meets the roof. And for wear tightness, we're installing a barrier, which you can see, the barrier membrane, you can see in these three photos across the underside of the existing ceiling, which has been removed to expose rafters and joists, apply the membrane to. Batten service zones, so that any cabling for lighting doesn't penetrate this air barrier membrane here. And so this is kind of the general principle, the approach to the way you kind of make the fabric airtight, better insulated. And in terms of windows, where you insert them, you think the trick with the windows is to think of them as part of the thermal envelope. So you try and get them as close in line with the insulation as possible. And you make sure that where they interface with your air tightness layer, you seal it up with a tape in some form or another. There are various sort of different approaches one can apply for that. And along with the air tightness, you can then test that with your air pressurization test. And here's Ben looking. There was a particular issue with the stove and the flue pipe from the stove going up into a register plate here in the chimney. But the result in the end of the day was still a very good result. Stoves always do pose a problem. They're always a kind of a weak point if you're in an airtight building. And then the final perhaps key component is heat recovery ventilation. Is where positioned here we have a fan which is both drawing air in and supplying it to habitable rooms, and then extracting it from wet areas, the kitchen, the shower room here, for example, and passing it through a heat exchanger so that you recover 80 to 90% of the heat from that and heating the fresh air coming in. So there are two air streams. You're not recirculating air, You bring in a specific amount of fresh air that's appropriate for the number of occupants in the building, and helping to keep that healthy internal environment that you're looking for. And then just finally, to finish, as a comparison, Harry is a co-director of 1540 architecture. He bought this terrace house in a couple of years ago, built in the late 70s. This is in South London, and he's managed to look at it and improve it. And he's actually this is the first building which is called a step-by-step NFIT Certificate 5 building, i.e. rather than just acknowledging that sometimes you can't always do everything in one go, but you can do it in stages. So he's designed and got certified the overall scheme that he would want to do to this particular 3-story terrace townhouse. He's used cork as another natural insulation alternative to the wood fibre used in Ben's house. He's already fitted his mechanical ventilation with heat recovery system. He has a particularly unique way of doing working drawings, quite different from mine, but this is his cork insulation. This is the existing wall here, and he's got this little inset. I think it's just as you go into the entrance there. So he's worked out how to get the continuity of the insulation there, and he's also applied this material along some of the way along the party walls to minimise the thermal bridge that you get at that sort of situation. He's involved in lots of things. One of the things he also had to do, and it's a general principle when you're kind of insulating buildings, that also, which the Passive House Planning Package also allows you to model, and to avoid overheating. You can model the risk of overheating, and in this case, is with these big south-facing windows, which were there when you bought the house, and all he's done is to fit triple glazed windows in. He's needed to provide some shading at certain times of the year to avoid that. So this is his kind of bespoke solution to avoiding that. So one of the key reasons why it's possible for Harry to achieve the NFIT standard where it would be very difficult for Ben is when you consider the form factor, which is the ratio of the external sort of insulated elements, both the walls, the roofs and the floor. In Ben's case, and largely driven by planning requirements, we've ended up with a form that's not the most compact of forms, but it works in terms of the relationship and relationship with the garden and the internal layout. Whereas Harry's house, he's got 2 party walls, which aren't external walls, so that he's got considerably less external wall. And the form factor in Ben's house, if that's 3.5, Harry's house is about half that. So in theory, although it's not quite as simple as this, he would need half as much insulation to achieve the NFIT standard as Ben would need. There's a few more it's a bit more complicated than that, but that's why compact buildings can have a kind of like a head start, if you like, in terms of being able to get down to the below 40, down to a level of 25 kilowatt hours per square metre per annum. I think I might stop there, and if you want to fire away with any questions. Has anyone written with the chat? Shall I stop sharing, or shall I? Lucy, what shall I do? Do you want me to stop sharing now, or?
We haven't had any questions come through yet to the chat.
Okay.
So by all means, carry on, and then I'll let you know when one comes in.
Okay. Well, I've got a couple more slides. It's just to finish with that. I gave this talk to the Hartford Civic Society at the end of last year, and they asked me to talk about sort of how to get good contemporary architecture in Hertfordshire. And so I kind of looked. I talked a little bit about the modern architecture movement in generally, and also has applied to specifically in Hertfordshire. But one of the mantras of the modern movement was form follows function. But somewhere more recently, someone, and I'm not sure who, has said form follows climate, and that's my next kind of mantra that I add on top of I guess the long life, loose fit, low energy approach to producing buildings that are kind of fit for our climate at the moment, fit for our needs to reduce energy usage and heading towards zero carbon. So I will stop there.
Excellent, thank you so much. So I've got a question from Joe. I'm looking at better insulating a Victorian terrace. Any particular resources I should check out? If it's likely to be a situation where internal wall insulation is going to be the solution to insulating the external walls, then I would look at Back to Earth are a supplier of wood fibre and clay and lime plasters and renders, and Chris Brookman there will give you very competent, comprehensive advice, and so the pitfalls of avoiding the risks of kind of, I kind of rather sped over it, but if you apply internal wall insulation, the risk point is where the solid brickwork on the inside is still at quite a cold temperature. Right. So as opposed to if you put the insulation on the outside, then the inside of the brickwork is going to be at a much more comfortable, warmer surface temperature. If you've got the insulation on the inside, then there is that risk of, if there's any moisture trapped in your fabric or moving from inside to outside in winter or from outside to inside in the summer, it condenses at that junction of the outer face of the wall insulation and the inside face of your brickwork. And when it's trapped there, that's where mold will grow, and that's where you can actually make your situation worse. Even though you've got a better insulated building, you're actually building in a health hazard. So that's the kind of thing that you need. And I would say builders are not particularly good yet at being aware of that. And so, yeah, if you want some advice, ask Chris. There are other builders, merchants who specialise in more ecological building materials and natural building materials.
And would that be the same if I was looking at external wall, which is another possible option?
Well, if it's external, then I think you could look at more higher performance insulants if you're happy to go, to consider using, expanded polystyrene or extruded polystyrene. But Chris would always say, no, just even on the outside, a natural material is better because it's breathable in the sense of just it allows moisture to kind of flow through the building as it wants to. Just doesn't get trapped anywhere.
Okay, that's brilliant. Thank you.
Yeah.
I have two questions from Ben. The first one being, they want to know about a boiler replacement. What is easiest in terms of dropping into existing system, air source heat pumps or electric?
I would say yes, air source heat pumps would be, which is what Nick was talking about last time, and they're improving products, and you could link it into your existing wet system. I don't know how your radiators were sized, whether they were kind of conventionally sized to a normal gas boiler circulation temperature or not, but
I think they were a bit bigger. I'd have to look back and
Okay,
remember,
okay.
but I think they were. Yeah.
Do you know what typically the flow temp is? I mean, yeah.
No, I'm not sure. I'd have to.
You just need to be looking at your boiler for 24/7 in order to work out what it's doing, dependent obviously on the external temperature. But the thing with heat pumps is, the lower the circulation temperature you can keep it at, the more efficient the air source heat pump will work at. So maybe it may be that there's one or two radiators that could, if they could be expanded so that they have an increased surface area, therefore a lower circulation temperature will allow them to output the same as they currently are. That might be. So Dick Warren, I think, when he had his fitted, and I would certainly talk to him and his contractor, he was very pleased with, based in Hoddesdon, I think. And I think he did replace a couple of radiators that were just to make the difference.
And secondly, if we get these £5,000 vouchers, what are the first things that we should look at? Is it double or triple glazing? Is it loft insulation? Can you point us in the right direction?
I guess, yes, if your loft isn't perhaps insulated as well as it could be, that would be where I'd first go, because is usually, apart from perhaps having to clear your loft out, and thinking about maybe building in a deck so that anything you want to store in your loft is not compressing the insulation. I helped my daughter and son-in-law do that in their flat in London, and they've got a continuous layer of insulation over the top of the actual ceiling joists as well as the insulation between the joists. So you're looking at 200, 300 would be even better. But otherwise, it's you're beginning other insulation improvements and maybe have a bit more disruption. I can't. I haven't worked on a project with double glazing for quite a long time, so triple glazing is I would certainly recommend. If only for the comfort, the fact that the internal surface temperature of a triple glazed unit is closer to maybe 16 or 17 degrees, which is, to all intents and purposes, the differentiation between that and the internal surface temperature of the solid wall around it is such that you just don't notice the cold spot that you might even notice between I've got double glazing here, I have to admit, and the insulated wall. The window does feel like it is cooler than the rest of the external wall surface. Some of the most disruptive area is when you come to look at insulating the ground floors. I mean, in Ben's case, it was relatively, I think it was a no-brainer, because in the extension there was a slab going down on insulation. So all it was within the existing building. It's just a slight variation on that. The slab, I think, was the same. It was just we were able to get a bit more insulation in the new slab, over the new extension, as opposed to within the existing building. But you can't, that is disruptive, and Ben was not living there whilst the work was being done, so that can be problematic. So, but likewise, also insulating between existing floor joists is also is not without risks of trapping moisture and accelerating the rot of the timber. So that is a difficult one.
I have one more question from Joe. Any thoughts on spray foam insulation on inside of the roof if you want to maintain headroom in the attic?
I think, as I understand it, the spray foams in that situation, I don't know what it's doing apart from potentially damaging the fabric. The foams are, some of them are moisture permeable, vapor permeable in theory, I think, but I think I'm very, very wary of using those kind of foam insulations
I've seen the protective equipment that the people who are applying it wear, and a client of mine, a developer client of mine, wanted to use that system to insulate a new build timber frame housing development, and I mean, I wasn't allowed in the building whilst this was going in. You know, I was thinking, right, so what once that's dry, when that dries, is that when it stops off gassing, or does it carry on, you know, producing potentially, putting chemicals into your building that maybe are not good for your health? I would be very wary of those kind of systems. Sorry.
Our final question, which may be answered very quickly, if you don't mind. What do you think of expanded glass balls? I'm using it under the floor in my front room, from Maura.
One of my fellow directors at 1540 has done this in her house, and she took a long time to persuade herself that this was perhaps a good solution to just basically fill up an existing void. She was concerned that it's just in terms of, you know, the insulation that around the timber is, if it is going to trap moisture, if there's any risk of moisture being in that part of the construction, and the insulations, because they are quite vapor tight, not allowing the moisture to escape, it will trap at that junction with the timber components. And so, but I think she satisfied herself that the permeability, vapor permeability of these beads is such that the risk should be quite minimal. And I think she did this now approaching 10 years ago, and I certainly haven't heard her say that she's had any problems. Or so yes, it is potentially a route to investigate.
Amazing, thank you.